Hey, what's going on, guys? We have this question right here. It's asking find the forces exerted by the pins on the members of the frame. So we have to find each of these each of these forces. So let's see what we can find from the outside. So first of all, we know we have AY acting on it and AX acting on it. Then we know this is 850 and C is gonna have a force. So let's say this CY. So from the outside look, let's see what we can find. So if I take a sum of horizontal forces, there's no other horizontal force acting on it, so I can take the one directly. So let's say sigma f of x is equal to 0 in statics. If I take this direction positive and solve for this one, ax comes out to be 0. Then we can, if I take fy, uh, the vertical directions, I have ay is unknown, cy is unknown, therefore I can't do anything about that for now. But if I take moment around a, if I take moment around a, I can calculate c. So let's see how we can calculate. So moment around a, if I take moment around a and solve for this one, we have ay and x will cancel. Then I have this 850 kilonewton pushing this object down, and therefore it's going to be acting clockwise, right? Acting clockwise, and the distance is 475 475, yeah. So 475 minus 475 times 850, then cy is pushing this object into clockwise, so it's going to be plus cy times 475 plus 50 is going to be 525, 525, 725. So this is going to be 725, and if I calculate cy comes out to be 639 Newton. So this is my cy. Now I can calculate ay by taking the summation of f of y equal to 0 in statics. If I take upside positive and find this one, ay is going to be positive, and 850 kilonewton acting downside, so it's going to be negative 850. Then cy is acting upside, so it's going to be plus cy is equal to 0. So if this is equal to 0, right? And if I solve for, we know cy already, we can solve for ay. If I solve for ay, I will get 211 Newton. So these are the values we can find from the outside. And now let's move to the pin B. So we have found these two exerted forces right here. So if we move pin B, let's see what happens. I draw the diagram first. It's going to be like this, B, and we have two forces acting on this side. So this is the forces are going to be let's say this is tension. The tension is going to be equal because both of them make equal, they are lifting you equal weight, so the tension is going to be equal. Let's say this is T, and the angle this one making is 66 degree. Therefore if I draw a Z axis, if this is 66, this is going to be 66. So from that I know this is going to be 66 degree. Then this is 60 and this angle is 90, therefore this is going to be 30, therefore this angle is going to be 60. So I know this is going to be 60 degree. Then what I can do, so from this one, so we have these two right here. So also we are gonna have a force acting in this direction. So let's say this is by, and that's all we. And if this has by, we also have bx acting on it. So that's all we need to know. So let's see what we can find from this information. So first of all, we know both t is equal to t. That's not a problem. And if I take horizontal components, this is going to be t cos 60, this is going to be t cos 66, so equal to 0, but we also have ax, not ax, it's just bx, right? Bx and unknown. So let's create the equation. So if I take sigma f of x is equal to 0 in statics, and if I take this direction positive and solve for this one, this is going to be negative t cos 60. Then we have positive t cos 66, and bx is going to be positive, so it's going to be plus bx is equal to 0. Then if I take y direction, sigma fy is equal to 0. If I take upper direction positive and solve for this one, it's going to be t sine 60. It's going to be negative because acting downside, c sine 60, and t sine 66, it's also negative, it's acting downside. So minus t sine 66. Then by is going to be positive because it has acting upside, by equal to 0. So from these two equations I can solve for by and bx. If I solve for that, I will get this is so this is 66 plus is 66. So if I solve for this one, I will get bx is equal to 79.3 Newton, and by is equal to 1512 Newton. So these are the answer I will get. Then from this one, let's move to the other part. This I'm taking this horizontal line. So if I take this one, it's gonna have by acting on the upper direction. So the thing we have to remember is, like, whenever I pick a direction here, whatever the direction connected with is going to be opposite direction according to the Newton's third law. Every action has equal and opposite reaction, right? So in this case, if I take by this side, it's going to be opposite here. Then if I take by this side, bx is acting this side, so it's going to be opposite here. Then we have this distance is given 275, and we have bottom distance 200, this is 125. Also we have an fg acting on this side, so fg is going to be this direction. So let's say this is the fg, right? And it's acting exactly in the 275 distance. And then we have, so we know the distance it's making is 100. So let's draw a small one. So here 100, this height is 125, and therefore the diameter is going to be 160. If you calculate, you will get 160. So I draw this thing separately. So this is going to be 100, 125, this is going to be 160. Then from this one I can form some equations. Also we have we have E right here, so it's going to be Ey in the upper direction. If Ey, then we are going to have a horizontal positive Ex. Then if I take equations for this one, let's see what we can find from here. So this is Fg, and if I take f of x, we have Ex unknown, Bx is known, and fg sine fg cos theta, that's also unknown. And if I take y direction, by unknown, by unknown, fg sine theta, that's also unknown. If I take moment around e, we know bx, we know by, we can find fg if I take moment around b, moment around e. So let's take that one first. Moment around so if I take moment around e, I will get rid of all these things, and fg is gonna be, I have to take fg cos theta. Fg sin theta is not gonna make any moment because it's exactly in the same direction. Fg cos theta will make a moment. So fg cos theta, instead of cos theta I can write adjacent over hypotenuse, so it's going to be 100 fg times 100 over 160, yeah, 100 over 160, then it's going to be in 125 height, and it's acting counterclockwise, right? So it's going to be positive 125. Then we have bx pushing this object counterclockwise, therefore it's going to be positive, plus bx, we know it's 79.3, pushing this object counterclockwise, the height is 300, 400, so height is 400. And what else we need to know? By is not gonna make any movement because it's exactly in the direction of e, so it's not gonna make any movement. That's all we need to know. This is equal to 0. Then if I solve for fg, I will get negative 406 Newton. Now from this information I can solve for bx and ex and ey. Vx and vy known, so I can solve for ex and ey. Let's take summation of f of x. If I take summation of f of x is use 0 in statics. If I take this direction positive, bx is going to be negative, minus bx minus ey minus fg cos theta. Instead of cos theta I can write 100 over 160. 100 over 160, we know the fg already. This is equal to 0. If I find bx, it comes out to be, I know bx, I have to find, this is some, I am taking ex here. So this is fg, then ex is going to be equal to 174 Newton. Then if I take summation of fy equal to 0 in statics, if I take upper direction positive and solve for this one, I will get ey positive. So positive ey plus and this is going to be minus by and fg sin theta, it's going to be minus because acting downside, minus fg sin theta. Instead of sin theta I can put 125 over 160, 125 over 160 equal to 0, and I can solve for ey. If I solve for ey I will get 1190 Newton. That's all we need to know. Then we have, so we found ax, we found bx by, we found exey, we found fg. We have to find d components, so dx dy. So I have to separate this one, so let's separate this. So I separate this picture right here. Let's draw this with a red color. Okay, here we go. So this is going to have a force right here and downside, right? Both of them are going to be equal force because it's both of them are in the both of them are pulling same weight, so it's going to be same weight, 850 Newton, and here also 850 Newton. Then we can find the angle that's making by using the Z, because if you see this is making 66 degree. If I draw a C line, it's going to be same angle here, 66 degree. So it means this is making 66 degree right here. Also we have dx dy acting on it. So that's all we need to know. From this one, let's see what we can find. So we have vertical forces now, and we have horizontal forces. So we can simply find by using summation of f of x and f of y. So if I take summation of f of x and solve this one, if I take this direction positive and solve for this one, I will get dx positive, and 850 cos theta is going to be negative because it's in the opposite direction, negative 850 cos 66. Then we don't have any other horizontal forces, so it's going to be equal to 0, and if I solve for dx, it comes out to be 346 Newton. So that's all we need to know, and we can find the dy by using summation of f of y. And if I take upper direction positive and solve for this one, I will get dy positive because it's acting upside, and 850 also upside, and it's going to be 850 sine 66 plus 850 sine 66, and we have 850 acting downside, so it's going to be negative 850 equal to 0. From this, if I solve for dy, I will get 773.5 Newton. So this is all we need. We found ax ay bx vy, fg exey dx dy c. That's all we need to find. I hope you guys like this video. See you next time.